Okay, here's my understanding of last week's assignment. So we're going to go through this pretty quickly. Okay, so we were given a data set. If you see down here, it says data, sheet 1, sheet 2, an example. So we're going to go with data first. So this is the NASP data file that professor gave us. The assignment, if you can read it, asks for this exercise, you need to use the NASP2 data NPA T Test data set, which is this. The question is whether managers with higher or lower salaries reported significantly different levels of job satisfaction in the NASP2 survey. Okay, so real quick, just so you understand what significantly higher means. If we go to book 3, wait a minute. Okay. So I asked the professor to explain to me what significance was, and the response I got was simply, okay, so if we look here at this example, so for example, we have a T-stat of 0.59 and a P of 56%, okay? These two values tell us that there is no significance because the T-stat needs to be in the tails. Because it's 0.59, it's within one standard deviation, positive, okay? The T and the P values are opposite. A significant finding means that the T value is large, meaning it's in the tail, so it's more than 1 or 2 standard deviations away from the mean. And the P value would need to be smaller than 5%, meaning there's less than 5% chance of us being wrong. On the second example, it is significant, okay, because the T-stat is negative 1.93, which means it's closer to being in the tails than the 0.56 up top. And also our p-value is closer to 5%. It's 8% here. And the reason that it remains significant, even though it didn't hit the 5% threshold, the professor said it's significant if we relax the p-value, meaning we increase it to 10% due to the small sample size. So that's what it's asking. We're looking for significance as defined by the t-stat and the p-stat, or the p-value. Okay, going back to our problem. So we have a data set, right? Okay, and it's asking us about job satisfaction. Lower annual salaries are defined as less than $75,000, whereas higher annual salaries are defined as more than $75,000. At the end of the data set, you will find 2 single item measures of job satisfaction for manager with lower, which is below, and another 3 for managers with higher, above. So first question is create one index variable of job satisfaction for managers with incomes below and one for managers with incomes above. Okay, so this is pretty simple. So we go to our data set, and we are going to copy and paste these 4 columns to say JSAT1 below, JSAT1 above, JSAT3 below, JSAT1, okay? Hold on. Go, baby. Go, go, go. There we go. Okay, so we would copy that into a brand new sheet, like here. Okay, and how we do our index variable, that's covered in a different video. Basically, you would sum it up. So I'll show you real quick. IV, let's put IV test, equal sign SUM, okay, and then we do plus sign, whoops, plus sign, this one, equals, and that's our index variable. So remember, index variable is just summing across the board, okay, and once you've done the first formula, all you have to do is just pull this down and it'll fill in the full formula for all of them across the board. Okay, so now we've done our index variable, which is why you see sometimes it'll say 0, sometimes it'll say 10. So on another video that the other, I think his name is Daniel. So basically what you would do, so now we got to get rid of all these zeros. So now you would copy and paste these 2 columns all the way down into another sheet, which we've done. Okay, and then you have options. You can go up here and you can sort them from smallest to largest or largest to smallest. The way he did is if you sort from largest to smallest, all your highest values go to the top, all your lowest values go to the bottom, and then we can just scroll down and find where 0 hits, and we can get rid of all the zeros. And the same thing with the IV above, okay? So then the way to run the T test, remember we always use unequal variances if the professor doesn't ask for anything otherwise, because it's the most conservative. The only time we would not use unequal variances is if we are using, let me take a look, paired to sample for means, meaning it's the same group at different points in time. Well, obviously this is not the same group at different points in time. This is two different groups, managers who make above 75 and managers who make below 75. So the way we do this is we would go up to data analysis. We go to assuming unequal variances right there. Hit OK. Okay, we hit variable 1 range is right here. Hold on. Okay. Go back. Variable 2 range. Give me a second. Okay, variable 2 range. Control Shift down. Okay. All right. Our hypothesis mean difference is 0 because we're always testing against the null set. We're checking off labels because we did include labels. We're going to leave our alpha as 0.05 because remember our alpha by default is 5%. That's our p-value. That's the probability that we want it to be below. Okay, our output range, all right, is where we want it to go when we're done. You click it right there, okay, and then you hit OK. Now, you get this gobbledygook. So the way you get rid of it is you can, hold on, scoot it over. Okay, I'm scooting it over. Okay, all right. Now we have all these decimals, right? So the way we get rid of those is we basically hold this down. Okay, we go back to home. We find these little decimal marks, so we bring them all out, and then we back them up to the decimal. So let's go to the second decimal. Okay, all right. And we click off. So what's important in this sense? The mean is important, so let's highlight, whoops, let's highlight that. I'm doing this one-handed. Okay. Let's go to, let me take a look. Page layout, formulas, home, data. It's not letting me really highlight it. Okay. Forget the highlighting. Okay, but what's important here is our mean. Okay, so we know our mean is 8.56. We're going to look at our t-stat. Our t-stat is negative 0.185. So, you know, it tells us that our t-stat is within 1 standard variation to the left of our mean. So it's pretty close. It's not in the tails. Okay, our p-stat, I like to look at it as percentages, so we turn that into a percent. And our p-stat's 40%. So our t-stat's not in the tails, and our p-value is 40%, which is significantly higher than 5%. So if we go back to the example that the professor gave me, basically how we would interpret that is that T and P are opposite. Okay, remember t-stat needs to be in the tails. Well, it's not. In this case, it's within 1 negative standard deviation. And the p-value is to be small, and it's not. It's large. So there is no significance. There is no significant difference to be read from that example. Okay. Again, t-stat needs to be larger in the tails. P-stat needs to be smaller, showing that there's less of a chance that we're wrong. So what this has shown is, again, we've tested this against the null hypothesis, meaning there's no real difference, there's no effect, And this has told us that these values, there's no significant difference between the managers that make above 75,000 and the managers that make below 75,000. Okay. The next question is, which type of t-test is needed? Perform the t-test and answer the question. Well, I just did. Obviously, the t-test that we'd use is the assuming unequal variances. It's the most conservative. We would not use the paired simply because it's not the same group at different points in time. They are two different groups. So hopefully this answers your question. If it does not, call me. And there we are.